Assalamu alaikum. I am starting a new journey of teaching you all the science subjects of grade 9th and 10th. Starting with chapter 5, there are three main states of matter, that is solid, liquid and gas. Remember one thing, that the particles of solids are closely packed together. The particles of liquid are a bit far apart from each other, while the particles in gases are very much far apart from each other. The closer they will be, the stronger the intermolecular force will be, the stronger they will be held together. As we move from solid to liquid and liquid to gas, the intermolecular forces between them become weaker because the distance. Now have a look on these diagrams. The molecules of gases are far away from each other. Their force of attraction will be low. Okay, they are a bit closer to each other, hence their force of attraction will be more than that of gases. And here there is almost no space between the molecules, hence their intermolecular forces will be the most stronger and will be greater than that of the liquids. Starting with the properties of gases. Indefinite volume. Indefinite volume means that as much as the space is available to them, it will spread in that space. Indefinite shape means that it will take the shape of the container in which it is placed. It don't have any definite shape. Just like solids, solid have a definite shape. It does not take the shape of the container. Liquid, it has indefinite shape. It takes the shape of the container. If it is poured inside a glass, it takes the shape of the glass. If in jug, it takes the shape of the jug. Then the other property is diffusion. Diffusion means the spreading of molecules from a higher concentration to a lower concentration. Here, the concentration of gases is more. It is moving from the higher concentration to the lower concentration. Taking the example of the perfume. If we spray a perfume in one corner of the room, if it is sprayed in this part of the room, now the smell of the perfume will spread in whole room. So the smell of the perfume is spread from one corner to the whole room, and anyone can detect that smell when he comes inside this room. So the molecules are spread from the higher concentration to a lower concentration, and all the room is now of same smell. In diffusion, the molecules come out one by one. They don't collide with each other. They come out one by one. Here, the molecules collide in each other and come and spread as a whole inside the room. Here, the molecules come out one by one. For the example of effusion, we are taking a can with a hole and molecules are coming out one by one. They are not coming all at once. On the other hand, we can take the example of effusion of onion smell from a bag. If we take a shopper in which the onions are placed, we tie it, but after some time we start smelling the onions. How? Because from the bag, the molecules are coming out one by one. In case of diffusion, when a balloon bursts, all the molecules come out at once. But in case of effusion, when there is a hole inside a balloon and the balloon gets smaller, so there is the escape of molecules one by one from the balloon. So this process is effusion. Now coming to the other topic, that is pressure. It is also a property of gas, and according to pressure definition, we all know that it is the force exerted on an area. So what does this mean? It means that force, here these arrows, they represent the force and this line represents the area. So how much force is applied on this area? This is known as pressure. Now for the unit of force, as a unit we all know that it is Newton, and area it is meter square. So pressure is the SI unit of pressure is Newton per meter square, and other unit for the pressure is Pascal. The other unit is the kilopascal. The Pascal is used for the smaller measurements, and kilopascal is used for the larger measurements. The next property is compressibility. What is meant by compressibility? Compressibility means that how much a substance is compressible. In case of gases, we took a container in which the gas molecules are there and a piston is above it. When we apply pressure with the help of the piston, we see that the gas molecules came closer to each other. We see here the volume is greater and here the volume is decreased with the increase of pressure. We can say that gases are highly compressible. The next one is mobility. Mobility means that how much a substance can move. Its ability of motion. Okay. Now gases are movable. Gases easily move from one place to another place. We studied in diffusion that the gas molecules move from the higher concentration to a lower concentration. It's their mobility. It's their ability to move from one place to another place. But why they have so much ability to move? Because of the weak intermolecular forces of attraction. They have weak intermolecular forces of attraction. This is why they move from one place to the other very easily. Next is the density. Density is the mass per unit volume. Means inverse relation and direct relation. In direct relation, mass increases, density increases. And volume and density are inversely related. So when volume increases, the density decreases. We know that the mass of the solids is more than that of the liquid, and liquid is more than that of the gases. Hence, the density of solid is more than that of the liquid, and the liquid's density is more than the gases. Here we have compared the three densities of oxygen in gaseous, liquid, and solid state. Now we will study the two laws, Boyle's law and Charles' law. According to the Boyle's law, the volume is inversely related to the pressure. With the increase of pressure, the volume is decreasing. They both are in inverse relation to each other. Now, whenever we will remove the sign of proportionality, we will write a constant. Here, V is equal to Kb multiplied by 1 by P. Now, we can write this equation as PV is equal to Kb. Here, Kb is the constant for Boyle's law. If we have two volumes, two substances that has a volume and a pressure, we can write the formula in this way, P1 V1 which is equal to P2 V2. The diagrammatic representation of Boyle's law, here we can see that the volume is greater and the pressure is low. Here the volume is low and the pressure is greater. They both are in inverse relation to each other. Here have a look that the pressure is less and the volume is more in this case, and the pressure is greater and volume is less in this case. They both are inversely related to each other as we studied in Boyle's law. Now here have a look on the graph. This graph shows that the volume is decreasing with the increase of pressure. The volume is inversely proportional to the pressure and temperature is constant. On the other hand, when we will move to the Charles' law, the volume will be directly proportional to the temperature and the pressure will be constant. This law states that volume is directly proportional to temperature. Volume is directly proportional to temperature. Boyle's law was volume is inversely proportional to pressure, in that the temperature was constant, and here volume is directly proportional to temperature. So which thing is constant? Pressure is constant. When we will remove the sign of proportionality, we will write a constant. What is constant over here? Here the constant is Kc. Now if we have two substances, two things, two cylinders, then we will use the formula as V1 divided by T1 which is equal to V2 divided by T2. Through this formula, we solve the numerical experimental verification for the Charles' law. We have a cylinder. The base is the heat conductor while the walls are the heat insulators. There are gas molecules, gas particles inside the cylinder and piston is above it. Now when we will provide temperature or heat to the cylinder, the gas molecules will expand. The gas molecules will expand and the piston will move upward. We can see that with the increase of temperature we provided, the volume increased. Here we see the direct relation. V is directly proportional to T. So the temperature increased, so volume also increased. Here pressure is constant. Pressure is constant. The graph of this law, we can see that with the increase in temperature, the volume is also increasing. Remember one thing, that time is an independent quantity. It will always be on the x-axis. On the other hand, we will always be on the y-axis. We will always be on the y-axis and then either it's P or T, it will be on the x-axis. Now we have studied both the laws. We already know that volume is present in both of the laws. So in Boyle's law, we can see here that Boyle's B is written in this way. So we can see that in B there is a P hidden. So Boyle's law, volume is inversely proportional to the P, and in Charles' law, volume is directly related to T. Next topic that we are going to start is the liquid state. There are few properties for the liquid state that we will study. The first property is the definite volume and shape. Liquids have definite volume but not definite shape. It takes the shape of the container. When we pour the liquid inside a glass, it takes the shape of the glass. When we pour it into a jug, it takes the shape of the jug. But it has a definite volume. The volume does not change. The other property is evaporation. For example, it's a liquid. The liquid evaporates and turns into vapors. So when liquid turn into vapor without the heat, then this process is known as evaporation. Evaporation takes place at all temperature. Place a bowl and put water inside it. See, after a few days you will see that the volume of the water will decrease. How? Because liquids evaporate at all temperature. The volume of liquid will start decreasing day by day because the water will be converting into the vapors without the supply of heat. Now in evaporation there are few factors that affect the liquid state: surface area, temperature, force. We can say for the surface area that evaporation will be more inside a huge bucket as compared to that of a glass. Because the surface area of glass will be less, the evaporation will be slow than that of the bucket. The surface area of bucket will be more, the evaporation will be greater. Now if the temperature is more, it means that evaporation will also be more. It also depends on the temperature. It is directly related to the temperature as it is related to the surface area. On the other hand, for the forces, force means that if the force of attraction will be stronger, if the force of attraction will be stronger, the evaporation will be slow. The forces are more. If the force is more, then the evaporation will be low. They both are inversely related to each other. And if the forces are weak, the evaporation will be higher because it will be easy for the particles to evaporate. Now for understanding better the concept of force and evaporation and that how they are related, take an example of water and acetone. Acetone is a nail polish remover. When we open the cap of the nail polish remover, we can feel that it is evaporating faster. It evaporates very quickly. However, on the other hand, the evaporation of water is slower as compared to that of acetone. The next topic that I am going to discuss is the vapor pressure. Now, what is meant by vapor pressure? Now, let us recall the concept of evaporation that we studied previously is that where there is a liquid and it is evaporating. The liquid is changing into vapors. Now, what is this? This is evaporation. Liquid changing into vapors temperature without giving it heat. This is known as evaporation. Now, if this is happening in a closed container, the liquid is evaporating. The liquid is changing into the vapors, and now as the container is closed, the vapors will again convert into the liquid. Liquid converting into vapors is known as evaporation, and the vapors converting back into the liquid is known as condensation. Now for the vapor pressure, when the evaporation becomes equal to the condensation, that pressure is known as vapor pressure. Here we can see that when liquid is converting into vapors, this is known as evaporation, and then vapors are converting back into the liquid, then this is known as condensation. Liquid converting into vapors, this is known as evaporation, and the vapors converting back into the liquid, this is known as condensation. In the beginning, the rate of evaporation is more. Liquid will first convert into vapors, then the vapors will convert into liquid back. So that's why in the beginning the rate of evaporation is more. Then the vapors will convert into the liquid. So with the passage of time, evaporation will increase and condensation will increase, and the time will reach when both will become equal to each other. Now what are the factors that are affecting the vapor pressure? Its nature, force, size and temperature. So starting from the nature, remember if it is polar in nature, it will have high boiling point and it will exert little pressure, low pressure. On the other hand, if the liquid is non-polar, then it will have low boiling point and it will exert more pressure. This is something point to remember. Now, force is inversely related to vapor pressure. It means that stronger the force, weaker will be the vapor pressure. Stronger the force, weaker will be the vapor pressure. They both are inversely related to each other. And according to the size, we can say that the particles, if the size of the particle is small, it will be easily evaporated as compared to that of the large particles. And if the temperature is more, vapor pressure will be more. They both are directly related to each other. Now coming towards the next topic, that is boiling point. For boiling point, remember that when the vapor pressure become equal to the atmospheric pressure, the pressure outside the container, it is known as atmospheric pressure. So when vapor pressure means that when liquid is converting into vapors and vapors are again converting into liquid, and when the condensation and evaporation become equal, this is known as vapor pressure. And boiling point is when the vapor pressure become equal to the atmospheric pressure. This is known as boiling point. Now remember one thing. During boiling, the temperature remains constant. If it's a water boils at 100 degrees centigrade and we are providing it with more temperature, what is happening in that water? The water is already boiling. Now, the temperature we are providing is not increasing the temperature of the water. What is it doing? It is overcoming the intermolecular forces of attraction of the liquid. It is not increasing the temperature anymore. It is overcoming the intermolecular forces of the liquid. Now the factors that are affecting the boiling point is the nature of the liquid and external pressure of the liquid. It is polar in nature, it will be having high boiling point. If it is non-polar in nature, it will have low boiling point. Now coming towards the external pressure, with the increase of external pressure, the boiling point also increases. If the external pressure is increasing, the pressure outside the cylinder or the pressure of the environment is increasing, the boiling point will also increase. In mountainous region, we have noticed that the external pressure is low and the boiling point is less. When the boiling point is less, it means that the low temperature will be provided to it and it will start boiling. Now coming towards the freezing point, if we decrease the temperature, the liquid will start cooling. Okay, the kinetic energy of the liquid will start decreasing, the vapor pressure will start decreasing. Now we all know with the decrease in temperature, the liquid converts into solid. So time will reach when the vapor pressure of the liquid will become equal to vapor pressure of the solid, and an equilibrium will establish in this. When equilibrium will establish, we will call it as freezing point. Now these are the three last physical properties of the liquid that we will study, which we have already studied in the gaseous state: diffusion, mobility and density. Diffusion was the movement of molecules from the higher concentration to a lower concentration. Now here we have a glass. If we drop little ink inside the glass in which water is present, the ink will slowly spread inside the whole water, inside the whole glass. The color of the water will turn into the color of the ink. Now remember the point that the diffusion in the liquid is slower than that of the gases. The molecules will move slowly. It will spread in the whole water slowly. And with the increase of temperature, the diffusion will also increase. Remember that with the increase in temperature, kinetic energy increases. Kinetic energy of the molecule increases, and with the increase in temperature, the diffusion also increases. Next point is mobility. Mobility, we discussed that it is the ability of the particles, it is the ability of the substance to move. The liquid molecules are also in constant motion. Now here they say that greater the kinetic energy, greater will be the mobility. Now how the kinetic energy will be greater? With the increase in temperature. So temperature is increasing, mobility is also increases. Kinetic energy, temperature, they all increases and the mobility increases. The other point is density. We already studied this as well, that density is inversely proportional to the volume and directly related to the mass. Density is equal to m by v, mass divided by volume. Density of solid is more than that of the liquid, and liquid is more than that of the gases. Here we are just comparing the liquid and the gases, that the density of liquid is more than that of the gases. Why the density of liquid is more than that of the gases? Because in liquid there is less space. The liquid particles are closer together as compared to that of the gaseous particle. Now we can also say that the liquid molecule also cannot expand. They have a fixed volume and they stay in that volume until we freeze them. Okay. Now the other topic that I am going to discuss is the solid state. Remember that the molecules in solid are in vibrational motion. They do not move as the liquid and the gaseous particle move. And the particles of solid do not diffuse like that of the liquid and gases. Properties, we will discuss it quickly as we have studied it 2 times. Volume and shape. solids have definite shape and definite volume. Okay, now melting point. What is melting point? When the solid converts into liquid, this is known as melting point. Solid is converting into liquid, this point is known as melting point. And when the liquid is converting back into the solid, this point is known as freezing point. Solid to liquid, melting point, and liquid back to solid, this is known as freezing point. Now coming towards the density in the liquid state, that the density is more than that of the gases. Why? Because it has less space between the particles than that of the gases. In the solid state, now as we know that the density of solid is more, then why the density of solid is more? Because the particles are closely packed to each other. We saw at the start of the video that the solid particles are close to each other. Liquid particles are bit far from each other. And that of the gases, they are very much far away from each other. So closer the particles, less will be the volume and greater will be the density. Volume is less, so density will be more. Volume is more as compared to that of gases. The density volume is more, density will be less. So we can say that with the increase in volume, the density is decreasing because they are inversely related to each other. Last property is rigidity. We know that the solid particles are close to each other. Hence, when we apply a little pressure on it, they will resist deformation. They will not change its shape. The shape of the solid particle, the shape of the solid substance will stay the same. Now coming towards the types of solid, there are two types: amorphous solids and crystalline solids. Amorphous solids, they both are solids, but what is the difference between them? They are not arranged in 3 dimensions, they are arranged in 3 dimensions. They are hard, but they do not have sharp melting point. Now what is meant by sharp melting point? Taking the example of glass, if we take 2 or 3 glasses, they all will melt at different temperature. If we take any crystalline substance like NaCl from any place of the world, the NaCl will melt at the same temperature. They have sharp melting point, and amorphous solids do not have sharp melting point. Crystalline solids are arranged in 3 dimensions. They are hard and have sharp melting point. Examples are here glass and plastic, etc. NaCl has sharp melting point and it has a fixed structure as well. If we break a particle of NaCl into powder form and we place the powder under the microscope, the shape, the structure of NaCl will still remain the same. That's why it is known as crystalline solid. Its structure, its shape does not changes even in the powder form. Now the next is allotropy. Allotropy means that one element exists in more than one form. What does this mean? Taking the example of carbon. Carbon exists in the form of diamond, graphite, buckyball. Now carbon is existing in different forms. So when one element exists in different forms, then this is known as allotropy. Now what are the reasons for allotropy? Allotropy, there are 3 main reasons for allotropy. One is that an element exists in more than one physical state. Now carbon, it is existing in 3 physical states, 3 physical forms: diamond, graphite, buckyball. Now the second is that an element has 2 or more kind of molecules. Okay, the second point is 2 or more kind of molecules. Example, O, then O2 molecule, then O3, ozone. Okay, so the first point was that existence of different physical states of one element. Second was different kind of molecules of one element, and the third is arrangement. Now if we take the example of sulfur, sulfur exists in both monoclinic and orthorhombic form. They both are different shapes, different structure we can say, but the arrangement, because of the arrangement of the atoms of the particles, sulfur is existing in 2 different forms. So this is known as allotropy. We studied 3 reasons. One is the physical state, carbon, diamond, graphite, buckyball of one element, that is carbon. Second is the existence of one element in more kind of molecules, oxygen molecule, ozone, etc. And the arrangement, difference in arrangement. Now sulfur existing in the monoclinic and orthorhombic form. Now remember one thing, that all the allotropic forms will have same chemical property but different physical property. Now coming towards the transition temperature. What is transition temperature? Transition temperature is the temperature at which 2 allotropic forms coexist. What does this mean? Now we have taken sulfur acid. It exists in two forms, orthorhombic and monoclinic form. The temperature here, what is the temperature? 95.5 degrees centigrade. The temperature at which the two allotropic forms coexist is known as transition temperature. Now what is the transition temperature for sulfur acid? 95.5 degrees centigrade. Coming towards the allotropes of carbon, we know that there are three allotropic forms of carbon: diamond, graphite and buckyball. And now we will study diamond, graphite and buckyball in detail. In diamond, carbon exists in cubic form. Each carbon is tetrahedrally bounded with four other carbon atoms. Each carbon is bonded with four other carbon atoms. Each carbon is bonded to four other carbon atoms. Here is one carbon, it is bonded to four other carbon. Now here in diamond, the covalent bond is very strong. The carbons which are bonded to each other, they have a strong covalent bond. We all know diamond is hard and it has high melting point. Diamond is a bad conductor. Now coming towards the graphite. In graphite, the carbon is arranged in hexagonal sheets like in this way. Here, each line represents the hexagonal structure. Here, hexagonal structure is present and sheets one above the other. Now here, each carbon is bonded to three other carbons. Here, each carbon was bonded to four others. Here, in graphite, each carbon is bonded to three other carbons. They have weak forces. We studied here that in diamond, covalent bond is strong, hence it has strong forces, but in graphite, the forces are weak. Diamond is hard and graphite is soft. They have high melting point and they are bad conductors, but graphite are good conductors. Buckyballs. Now what is buckyball? Buckyballs are carbon atom. They are the allotropic form of, it is also an allotropic form of carbon. Here 20 to 100 carbon atoms are present and these carbon atoms are arranged in hollow cage like structure. Now what is hollow cage like structure? We all have seen football. So in buckyball, the carbon atoms are arranged similar to that of the shape of the football. Buckyballs, they are used as semiconductors and they are superconductors. Here came the end of my first lecture. Hopefully you all understood, and if you have any question, let me know in the comments below.